In this lesson, we talk about trigonometric substitutions. These are the kind of substitutions that we use in the integrals that we have certain terms that we need to use trigonometric substitutions. There are several kinds of trigonometric substitutions. In this lesson, we focus on one of them that I'm going to explain. Sometimes in the function that we integrate, we might see something like the integral of 1 minus x squared or radical of 4 minus x squared or radical of 25 minus x squared. Or in general, we might see somewhere in the function the term of radical of a squared minus x squared. So for these kind of functions that they have a term like this, there is a very helpful substitution that we are going to work on today. Like for the first one, 1 minus x squared, we let x be sine of t. Later we'll see that why this substitution is very helpful. For radical of 4 minus x squared, we let x be 2 times sine t. For integral like that contains the term of radical 25 minus x squared, we let x be 5 sine t. Or in general, if it is radical of a squared minus x squared, and a is a constant, obviously comparing to the previous cases that we saw here, x is going to be that constant a times the sine t. So based on this explanation, let me write a note here. If the function has a term radical a squared minus x squared, as I mentioned, a is a constant, then x equals a sine t can be a helpful substitution. Be careful, this kind of substitution is different from the previous substitutions because usually u is a function of x. We take u to be a function of x, but here the variable x itself will be a function of another variable like t. We can use any other letter instead of t, but t is the most common letter in this discussion. Now, when I let x be a sine t, x is a function of t, although x is the variable of the problem, but on its own, it's a function of t, and a is a constant here. So what is the derivative of x with respect to t? A cosine t. And therefore, the cross multiplication tells me that dx is a cosine t dt. So if I let x be a sine t, then dx is a cosine t dt. Now let's see an example or a couple of examples that we see that how this works and why it is very helpful. So in the first example, we want to evaluate the integral of 1 over radical 25 minus x squared dx using substitution. Some of you might think that this is a very familiar integral to you, and you might even know the answer. But we are trying to do this by using the substitution. So I see that here there is a term of radical 25 minus x squared. So if I want to use substitution, x is going to be what? That 25 is like a squared. So a is 5. So that 25 is a squared, so a is 5. So I let x be 5 sine t. I just explained here that if x is a sine t, dx is a cosine t dt. So here dx is 5 cosine t dt. So this is the substitution that we use for this integral. So this is going to be 1 over radical of 25 minus x is what? 5 sine t, then squared. And dx is 5 sine t dt. So this equals the integral of 1 over radical 25. 5 sine t squared is 25 sine squared. And then 5 sine t dt. Excuse me, I made a mistake here. This was 5 cosine t dt. This was 5 cosine t dt. Because dx here is 5 cosine t dt. Okay, now you see that why we let x be 5 sine t. Under this radical, we see that 25 is in common between these two terms. So I can factor that out. So it's going to be 1 over radical 25 times 1 minus sine squared of t. 5 cosine t dt. 1 minus sine squared is cosine squared of t. Let me continue this integral here. So I have integral of 1 over radical 25 is 5. Radical cosine squared is cosine t. And on the top, I have 5 cosine t dt. So now we can simplify this easily, right? So 5 cosine t and 5 cosine t, they cancel out. It's integral of dt. In fact, this means integral of 1 dt. It's not common to write 1, but that's what it means. Antiderivative of 1 is t, so it's going to be t plus c. But I need a back substitution. I need to rewrite this in terms of x. For here, we need a little bit from pre-calculus. Look at x equals 5 sine t. how can I write t in terms of x? If I divide both sides by 5, x over 5 is sine t. If sine t is x over 5, how can I write t in terms of x over 5? That we use the sine inverse or arc sine to be consistent with the notations that you will see in your homework assignments. Let me go with that sine inverse sine, and we put a -1 on the top, on the right, upper right corner of sine for showing the inverse of sine. So here t is gonna be sine inverse of x over 5. So for that reason, the final answer here is sine inverse of x over 5 plus c. Let me write another example, and please try this on your own. Although this example is a little bit more complicated than the previous example, although from the beginning it doesn't look like to be more complicated. Integral of 100 minus x squared dx. I want to use an appropriate substitution and do this integral. Obviously, that a squared here is 100, so I let x be 10 sine t. And dx is going to be 10 cosine t dt. Again, where this 10 is coming from, that 100 is like 10 squared. And when we have a squared minus x squared under the radical, helpful substitution is x equals a sine t. In this example, a squared is 100, so a is 10. That's why we let x be 10 sine t. And dx is 10 cosine t dt. Okay, so this is the substitution that we need. So this is going to be the integral of 100 minus 10 sine t all squared. And dx is what? 10 cosine t dt. Under the radical, we have 100 minus 10 sine t squared is 100 sine squared of t. And then times 10 cosine t dt. Under the radical, both terms have 100 in common. I can factor that out. 1 minus sine squared t, then 10 cosine t dt. 1 minus sine squared is cosine squared. Let me continue here. So I will have a radical of 100 is 10. Radical of cosine squared is cosine t. And then times 10 cosine t dt. In the previous example, one of these, like in the previous example, we had 5 cosine t on the top, 5 cosine t at the bottom. They canceled out. The reason that this example is not as easy as the previous example is both of these two 10 cosine t's are on the top. First of all, 10 times 10, 100. Let me pull that out from the integral, and I will have cosine squared of t dt. As you know, in one of the recent lessons, we have discussed integral of cosine squared. Do you remember how we dealt with that? So let me continue on the next page. Integral of cosine squared t dt. As you might remember, we used the trigonometric identity that cosine squared of an angle is 1 plus cosine of twice that angle, cosine of 2t, all over 2 dt. I can pull out that 2, it's in the denominator, so I will have 100 over 2, which is 50 times the integral of 1 plus cosine of 2t dt. Antiderivative of 1, so this 50 times, antiderivative of 1 is t. We are integrating with respect to t, so the antiderivative of 1 is t. Antiderivative of cosine of 2t, do you remember when we had cosine of k times the variable? Antiderivative is 1 over k sine of k times the variable. So antiderivative of cosine of 2t is 1/2 times the sine of 2t, and then plus c. Then we distribute 50 over the parentheses. It's going to be 50t plus 50 times 1/2 times sine of 2t. 50 times 1/2 is 25. 25 sine of 2t plus c. One of the complications that we have here is to write this in terms of x. For 50t, it's simple. So for 50t, we know that what was the substitution? X was 10 sine t. If x is 10 sine t, t is sine inverse of x over 10. Let me briefly explain this here. So the substitution that we use, x was 10 sine t. So if I divide both sides by 10, sine t is x over 10. In other words, 10 is sine inverse of x over 10. As I mentioned, in trigonometry, sometimes the other notation which is used for sine inverse is arc sine. So that's why here, that t that we have here is going to be sine inverse of x over 10 plus this part, we do it in a little bit different. So 25. Do you remember from pre-calculus, sine of twice the angle? Sine of 2t is going to be 2 times sine t cosine t. So sine 2t is expanded as 2 sine t cosine t. This is something that you have seen in pre-calculus or any trigonometry course. Okay, so let's see what we have so far. The first term was 50 times sine inverse of x over 10. 25 times 2 is 50 sine t cosine t. Sine t in terms of x is easy. Why is it easy? Because x is 10 sine t. So sine t is x over 10. Again, let me use the next page. X was 10 sine t. So sine t itself is x over 10. Let me go back here. Sine of t is x over 10. How about cosine of t? How can I find out the corresponding value of cosine of t? You know that sine squared plus cosine, let me do it here. Sine squared of t plus cosine squared of t is 1. So sine is x over 10, so x over 10 squared plus cosine squared of t is 1. And you can solve for cosine of t. So this is going to be x squared over 100 plus cosine squared of t equals 1. Subtract x squared over 100 from both sides. So cosine squared of t is 1 minus x squared over 100. So 1 minus x squared over 100. The common denominator is 100. The top becomes 100 minus x squared. So cosine of t is the radical of that. The radical of the top, I can't do anything about that. Remains radical of 100 minus x squared. Radical of the bottom is just 10. Radical of 100 is 10. So cosine of t with this calculation is radical 100 minus x squared over 10. So that question mark, in fact, is radical of 100 minus x squared all over 10. So if I want to write down the final answer, here is the final answer. So the first term is here, 50 times the sine inverse of x over 10. Then what? 50 here, there is a 1/10 here because it's x over 10, and under the radical is another 10. Those two tens are in the denominator. The 50 is on the top. 50 over 100, 10 times 10, 100 in the denominator. 50 over 100 is 1/2. Then what? X of x times radical of 100 minus x squared. And this will be the final answer. And since it's an indefinite integral, don't forget plus c at the end.